Here's an implementation of Simon in MSP430. This is a prototype version with a single RGB LED that flashes a sequence and a button for the user to repeat the pattern. The number of flashes is random and can happen for anywhere between 1 to 4 times. Then it waits for the user to enter the sequence for 4 seconds. If the input was correct, it flashes green, otherwise it simply moves on to the next sequence. Let's try it out. Here the sequence begins. It flashed for 4 times, 1, 2, 3, 4, and it just flashed green, as you could see. If I flash it 1, 2, 3 times, I get a green. But if I flash it an incorrect number of times, it will just move on. So there it flashed 2 times, I'll flash once, and it just moved on. There were 2 big challenges in implementing this lab: creating a pseudo-random number generator or PRNG and implementing a debouncing. To create the PRNG, I used a linear feedback shift register. The next value of the register is an arbitrary linear function of past state using exclusive OR gates. The code for the implementation looks something like this, where you can see I shift the register 10 times, 12 times, 15 times, 13 times to take it to the 0th bit position. I do the exclusive OR over there, and then I am only concerned with the value at the least significant bit. And then I return the modulus 4 and then add it to 1 to give me a random number between 1 and 4. Let's take a look at the PRNG in action. I have declared a global variable n_iters, and I have assigned it to my PRNG function. And I've also set a breakpoint, so when I'm debugging I can take a look at the values that it takes on. So let me play it over here, resume. 3 changed to 2, and then this is gonna take some while because it's happening in the interrupt, and the interrupt happens only every fraction of a second. And that turned to 3, that to 1. It's again taking time. We're back, we get another 1. So as you can see, we're getting somewhat random numbers. I mean, I have no idea what the next number is going to be. To implement the debouncer, I started off with a hardware implementation. I connected a capacitor in parallel to the button to create an RC circuit. The time constant is large enough to prevent any bouncing of the button metal contact. So with the hardware implementation, it looks something like this. It's hard to do things with one hand. Alright, so that was how I did the hardware implementation. And then once I had an accurate estimate of the time constant that I wanted, I moved on to a software implementation where I used a timer and a flag to tell me if the last interrupt executed was a couple of milliseconds before the current one. If it was not within that time window, I increment the number of times the button was pressed. Here's what it looked like. So this is the interrupt for the button press, where I'm using the absolute function from the math library to compare the window of times. The actual logic behind the game is implemented in another interrupt, the timer interrupt, which works in the MC1 mode, where it counts up to CCR0. And in this code I'm varying CCR0, as you can see over here.